Right, for this reassessment, I'm going to be looking at vectors and forces. The problem basically states a canoe goes directly across a river at 3.5 meters per second. The water flows at 2.0 meters per second and is 698 meters across. What is the resultant velocity of the boat? So in order to solve for this problem, we first have to identify a couple things. We know that our velocity of our canoe basically is 3.5 meters per second. Our flow of our water, or the velocity of our water, is 2.0 meters per second. And I derived the width of the river going across basically as delta dw, which is the distance of the width going across. So in order to find our resultant force, we can use the Pythagorean theorem to basically break down the problem and give us part of our answer. But we're also going to have to use an equation in which we have to solve for theta, which we're going to identify later in the video. But to first start off, we need to know our velocity of our resultant force in our x direction and our y direction. I basically started by drawing a free body diagram, which kind of helped me to identify what is our resultant force in our x and y direction. And basically what I said was our x direction is going to be going across the river, so our resultant force for x is going to be 3.5 meters per second, and then our resultant force in our y direction is going to be the flow of the water, which is 2.0 meters per second. So if we go back and we look at our problem and we plug it into our resultant force, we're going to get the square root of 3.5 meters per second, which is our resultant force in our x direction, plus 2.0 meters per second squared is going to be our resultant force in our y direction. So if we plug that in, we get a resultant force of 4.0311 meters per second, which I rounded to the nearest decimal, and we get 4.0 meters per second. So that's how we first solve for the first part of the problem. The second part of the problem is that we're going to have to solve for theta. Kind of an easy way to do this, I set it up in terms of trying to figure out what our resultant force would be of the unknown angle. So in order to do this, I put that we have our canoe going in our x direction. The flow of the water is going to be 2.0 meters, so 3.5 meters per second is our x direction, 2.0 meters per second is our y direction. But if we draw that in terms of a right triangle, we know that 3.5 meters per second, if we look at this, is going to be our opposite angle divided by our adjacent angle. And if we look in terms of SOHCAHTOA, we know that opposite over adjacent is going to be our tangent function. So therefore, we know that we have to solve for theta in terms of tangent. So if we plug that in, we're going to be looking at theta equals the inverse tangent of 2.0 meters per second divided by 3.5 meters per second, and we get that theta is 29.745. Rounded to the nearest whole number, we get that theta equals 30 degrees. So from the problem, we were able to solve for our resultant force, and we get an answer of 4 meters per second at 30 degrees. So therefore, that is how we solve for the resultant velocity of the boat. Thanks.